Hello and welcome to this week's What Were They Thinking? We begin with some of the unexpected and surprising side effects of serious cases of infection by the CCP virus. There are ongoing reports of significant hair loss if you have a serious infection with the CCP virus. This is being further corroborated by social support groups, those being on Facebook and community-based. More people are describing how their hair is coming out in larger and larger quantities once they've been infected by the CCP virus and then recovered. This is being further supported by doctors reporting on it. The doctors at least have some idea about what is happening. They call it telogen effluvium. It's a condition in which the body, to put it in simple terms, prioritizes recovery and support of other systems. This means the hair gets less nutrition and oxygen, leading to significantly more hair loss. Under normal circumstances, this would normally recover in somewhere between 3 and 6 months. The problem with the CCP virus is, we don't know how long side effects like this might last. Recovery is one thing that we're looking at as an important factor, and why so much effort is going into development of vaccines. But where vaccines aren't yet available, other drugs might be repurposed. 21 such candidates have been identified. This is 21 candidates out of a possible nearly 12,000 at the Reframe Drug Repurposing Library. These are all drugs that have either already received approval for use or got to the very late stages of clinical trial testing. This means that doses, safety, and more are all well understood and known. The advantages of doing this is that it can cut down the time required to get these drugs to market in an effective and safe way. Consider how much time and effort it would take to create an entirely new drug, or vaccine for that matter, even in the current situation where we are pushing more and more resources into developing these things. We've spoken about one of the candidates already, remdesivir. This drug has shown considerable benefit in reducing the duration and severity of infection by the CCP virus. That means there are still at least 20 new drugs that could be tested. Of the 20 that are there, 13 already have safety and effective concentrations known for use with the CCP virus, and they have already had clinical trials run to test them in other capacities. That means we have a large number of drugs that could reduce the duration and severity of the CCP virus, allowing us to cope better with the outbreak now until a vaccine is released, and while the vaccine is being deployed effectively, we can treat and effectively control the disease itself, allowing people to have less likelihood of dying and better outcomes even if they are infected. While we're looking at possible ways to treat and allow for the fact that a vaccine may not be available in the immediate future, we need to look at what's going to happen in the current measures available. Many people have publicly criticized and complained about stay-at-home, isolation, and social distancing measures. All of these have been to some extent criticized by those who know what they're talking about and those who don't. In many cases, those who know what they're talking about have explained how hard it is to make them work. The idea is to drive down the spread to a rate of less than 1. This is known as your R value. If the R value is below 1, then the spread decreases as fewer people are infected each time an infection occurs. If it's above 1, it will grow. The fact is, we've had a lot of trouble being able to demonstrate just what the benefit is, especially in America. Looking at data from one study that used 211 counties covering more than half of the US population, there is undeniable evidence that social distancing and similar measures work. There is no question, there is no doubt. What they also looked at was 2 other factors. That is, density of the population, and whether or not temperature would affect this again. What they found was that temperature was a variable that they could not predict reliably. Population density was a different matter. It was doubtful that there would be a negative relationship between the two, and that's exactly what they found. The higher the density of the population, the more the spread occurs, and this is just plain sense. If you can't move away from people to create distance, you can't social distance. This leads to more people being exposed to anyone who has been infected. Putting this in context, implementing and enacting effective policies that allow for social distancing and isolation leads to a nearly 50% drop in the spread rate. This could increase to nearly 60% when you expand the scope to include non-essential businesses. That is a huge decrease in the spread, even allowing for density of populations and weather changes. While talking about numbers and statistics, we want to bring up a particular incident with Georgia. Georgia has been publishing on a reasonably regular basis a heat map of the outbreaks in that state. This is a really useful tool if you are trying to explain to the public just how the disease is spreading. What we have here is a particularly problematic example. Between 2 days, there is a 50% increase in the cases, yet the heat map does not change, and this is a big problem. What it shows is that Georgia is moving the goalposts each day, and, in effect, failing to communicate the severity of the outbreak and how it's increasing. If you look at the simple side-by-side cases per 100,000, they look no different using Georgia's Public Health Department's method. If you were to try and keep a consistent standard, you would note that the number of red areas would increase drastically between 2 days, let alone the darkest blue and everything else. This is a case of lies, damned lies, and statistics. Or perhaps it should be lies, damned lies, and Georgia's health department. While talking about various things like this, we want to highlight a very good infographic about how you can decide whether or not you want to leave your house to start with, and whether or not you would be acting in a manner that is safe, considering things like Georgia's significant increase in the outbreak. They give what you can simply put as a traffic light measure: green for go, yellow for be cautious, and red for is stop. They do this by clearly telling you what they're trying to measure as a risk factor, then what you can do about it, such as wearing a mask. They then provide 5 different categories and the activities that fall into this, the lowest risk being to walk your pets and engage in relatively isolated and independent activities, or better yet, not leaving your home. Then they get progressively more risky, going from staying at home to getting your groceries and then traveling within a shared public transport system like a taxi. Then the higher risk activities, such as going to a restaurant or getting your hair cut, and then finally the highest risk activities. These different differentiations are important when you consider whether or not you want to reopen your business, for example, or provide services, since each could be at a different level of risk. If you're in a state and you're involved in administration of the law and deciding whether or not you want to open up more or implement more severe restrictions, the same considerations apply, and it's one of the reasons why many states are wary of reopening extremely quickly. One of the best pieces of advice you can get is to wear a mask unless you are a Karen and believe the mask will cause you harm. But then again, they rarely know what they're talking about, which is why scientists will often test which mask is best to work with, and some of them have done exactly that, for public consumption, not necessarily as a quality control measure. In this case, they recorded videos of what happens when you wear a variety of masks. Some of these are homemade, some of them are commercial. The difference is important. If you're looking at a surgical mask, such as an N95, which has a set standard that it must meet to be labeled such, you can expect to get a very reliable result. But you need to be aware of the fact that they cost money, they are disposable, and they are in short supply given the health sector needs them more than ever. This means people are often making do by creating their own. The video recorded 3 examples: the N95, 2 homemade versions, and a bare face. You can think of the N95 as a control measure, as is the bare face, but how would the homemade masks perform? The simple version of what they found is, the more layers you have, the better. The tighter the weave of the material, the better. That means that you can reduce the number of droplets and the amount of viral particles getting out by a large margin simply by wearing more layers in your mask. Many countries are demonstrating great efficacy in doing so, Japan and Korea for example. Japan has done it for a long time, both as a courtesy to others and as a health measure, simply by being conscientious. When we're looking at something more mundane, like everyday use, there's less use for it. But when we're talking about an environment like today, where there's an epidemic, you may wish to adopt some of these other practices. If you are going to make your own homemade mask, then there has been a very useful article coming out of the conversation, and it tells you how you can test your mask to see whether or not it's going to be effective. To be honest with you, a mask itself is not the appropriate term, as there are certain legal definitions for that. It might be more appropriate to call it a face covering. When we're talking about face coverings in general, you need to consider the size of the particles we need to measure. A virus particle in this case is going to be about 0.08 micrometers. The gap between the fibers in your typically woven face covering is going to be between 1 and 0.1 millimeters. That's a 1,000-fold difference between the viral particle size and the gap size. That does not mean it's not going to do anything. For a number of reasons, first and foremost, the virus particle may only be 0.08 micrometers, but the virus particles clumped together in a droplet are substantially larger. This means that where a small virus particle might travel a long way by itself, that distance is shortened. Then when you have multiple layers between your mouth and the outside world, these large droplets get caught, buffered around, and lose their momentum. This means simply wearing multiple layers of protective layers in front of your face slows down the movement of particles even if you cough and talk. That means they only go a short distance, less than a meter generally. If you keep your social distancing of 1.5 meters or roughly 6 feet, you stay outside of each person's possible zone of infection. But that doesn't help if you don't create a mask that works. And that's where these tests come in. There are 2 that they describe that are particularly useful. First, you could try blowing something like a vapor or smoke. If it goes out the front of your mask, the mask has not worked. If instead, the vapor or smoke hits the mask and goes down towards your chest or out behind your face, this means that the vapor is being redirected and blocked by the mask effectively, and a similar phenomena would occur with any virus particles or droplets from when you are breathing or talking. The second test, which is more useful if you have an objection to trying to blow something like this, is to take a candle, place it in front of your face by a short distance, and try to blow it out. If you are successful, your homemade mask is not going to work. If it doesn't work and you can't blow out the candle, then your homemade mask has been a success. Finally, the last bit of news about viruses, and it's something of an animal study and virus study. We've been trying to understand why bats are such a good reservoir for viral diseases, but not only that, how do they survive being infected for so long and so effectively? Consider how much damage this CCP virus has done to humans, and yet bats get by. The earlier SARS outbreak from the early 2000s was only in the last 10 years identified as being from bats, and it's taken us a long time to figure out just what it was. There are a lot of bat species, most of them are infected with viruses, and yet they keep going. This means we have to wonder what's happening, and a genomic investigation has identified a series of things that contribute to the bat's ability to survive. One of these, and it's perhaps the bigger one, is that they don't have a series of genes involved in immune responses, the important one being an inflammation-mediating gene. If this gene is not there, the immune system doesn't function effectively. One of the big causes of damage in humans when they become infected is the inflammation response. The body gets heated up, enzymes take action, and there's a variety of actions by the immune cells to destroy the virus. This leads to lung damage. The bats do not get this because they don't have some of the necessary genes to stimulate that response. That means they don't get damaged in the same way as the human body does. That allows them to get by and survive despite being infected, not just by the CCP virus or for that matter other coronaviruses, but from genetic testing a large number of viruses throughout the species' evolution and development. That means we can't take the findings with the viral elements and apply them to humans effectively, but it might be useful in longer-term research into how we could work around some of the viral infections. While we can't make the bat virus research work for us, we have been able to wake up 100 million year old microbes. Understand that these microbes are older than human agriculture is by millions of years. We only started farming about 10,000 years ago, and the microbes that were sourced from one of the deepest, least hospitable places in the world, the bottom of the Pacific Ocean, are more than 100 million years old, and we could wake them up and start growing them in a lab. Researchers were doing this to try and figure out whether or not you could even revive these particular species, given where and how they survived. The bottom of the ocean seafloor has very little nutrition, very little oxygen, and there's no light to speak of. This means surviving there requires a lot of resilience. By giving them just a bit of nutrition, a little bit of oxygen, and a little bit of support, researchers were able to revive the species. These particular bacteria are very different to others in that one important caveat exists. They were not spore-forming bacteria. Spore formers are well known for their ability to be resilient to any inhospitable environment, where they go dormant and then wake up when the environment becomes more suitable. Instead, these ones were normal bacteria that had simply been able to work through this harsh and cruel environment to survive for millions of years. The bacteria that they cultured were so effective that in a little over 2 months, they were able to use all the carbon and nitrogen in the media they were being grown. That means that they were surprisingly healthy, and grew to a large quantity. While we're talking about bacteria, we should talk about the opposite end of the spectrum, where before we were at the bottom of the ocean. Bacteria grown in zero gravity are able to effectively develop antibiotic resistance and be more lethal. Experiments developing and growing bacteria in space have found a number of interesting and, as mentioned, particularly disconcerting results. These include reductions in cell size, meaning less chemical reaction and interaction to antibiotics. They've also developed behaviors for how they grow that makes them more aggressive and resilient to treatment. If we were to look at this in context of what would happen if bacteria came from outer space and crash landed on Earth, we'd need to be aware of the fact that when they first arrived, they would be more aggressive and be capable of being a harsher pathogen than what is already here, and it would retain that pathogenicity for quite some time after their arrival. The reason this happens owes to a number of different things. The important ones, though, are that reduction in cell size, meaning they're less vulnerable to the effects of a chemical reaction, such as being hit by antibiotics. What also happens is that they mutate more effectively in space. Some of these mutations include the development of a better, larger, and more dense biofilm. Biofilms are a structure that allows cells to get close to each other and provide support, effectively metabolizing things in their environment. This is then surrounded by a matrix of polymers. The polymers allow them to hold themselves in place and stay safe because they're protected with a physical structure. In space, you need this, as there's very little in the way of structures, like on Earth, to hold on to, nor is there a gravity to keep you set in position if you are a bacteria. The combination of increased mutations, biofilms, and reduction in cell size means they can do a lot more damage. While talking about damage, we should mention an interesting court case coming out of California. There's a legal case being made against California's Juvenile Correction Services, in which a young boy was given estrogen injections. This is not fundamentally unusual. Estrogen injections are used for several things, but in this case, he was being given them as an experimental treatment for oppositional defiance disorder. This is a psychiatric condition, and it often leads to issues complying with authority, leading to outbursts, temper problems, and sometimes violence. The Juvenile Corrections Service was giving him these injections to control his behavior. That, again, is not so unusual if it's an experimental treatment, but it has one big need. That is informed consent, and they did not have it. The underage child's parents did not consent to treatment, and that is a big problem both from a professional standards point of view and from a legal point of view. Experimentation on humans requires informed consent. Treatment of any kind requires informed consent, and the Juvenile Correction Services failed in both regards. And this has led to the child being given multiple doses of estrogen to control his behavior. It then gets worse. As a result of multiple injections and then oral administration of this medication, he began to develop gynecomastia, or breast tissue. This then led to him being bullied and roughhoused in the Juvenile Corrections Service. That then leads to the court case in question, where the lawyers have argued that the only way to deal with the outcome of this treatment, experimental treatment, is through surgery. While the court case is yet to be settled or otherwise resolved, it's worth being aware of. Next, we need to talk about shipments of mysterious seeds coming from China to America. These mysterious seeds are winding up in people's hands despite neither ordering them nor wanting them. The problem with this is one of biosecurity and quarantine. For all we know, these seeds could well be invasive species, diseased, or worse, contain insects that are a dangerous species for America's agriculture. This is why the USDA is telling people to contact them, do not plant the seeds, and then let them tell you how to deal with them. The concern with this is simply that if they are an invasive species, they could outcompete what is already in America. Worse yet, they could cause harm to agricultural industrial areas, especially those that have the ability to crossbreed with whatever seed the new one is. That would ultimately lead to issues regarding whether or not offspring of the new plant would be fertile, whether or not the plants would even be what you think they are, and worse. Finally, we have some interesting news about Stonehenge. Stonehenge, for those of you who are not aware, is a Neolithic wonder. It is a massive stone structure made up of a series of freestanding stone plinths, and almost looking like archways or doors. How this was made has been a mystery for a long time. After all, they are massive stone structures built thousands and thousands of years ago by people who we thought had no ability to do so. Looking at the structure itself, it's currently thought, based on particular scans of the stone and the elements that make it up, that the bigger structures, those arches, were sourced from a location about 25 kilometers away from Stonehenge. Again, not that horrifying or worrying, except each stone weighs 30 tonne, or roughly the equivalent of a large transport truck. They were moved roughly 4,500 years ago. Those 25 kilometers plus massive weight 4,500 years ago means that this site had to be the consequences of a huge industrial effort by the ancient Britons. That leads us to wondering not only why they did it, but how they did it. And that's the ongoing mystery of Stonehenge. We may now have some idea how they are able to source the stones from an area known as the West Woods, relatively near to Stonehenge, how they would transport them if they did at the time, and to what degree they had to work around it. This site could not have been made if it were not something similar to a nation-building project. We've had similar phenomena in the last 100 years with things like the Suez Canal, but those efforts were huge. They were considered massive achievements of their time, and it's why Stonehenge is a wonder of its age and even now. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please share any comments, questions, or suggestions you have below.